Okay, I think it should be done now. I hope. Okay, hello. I am Kisanapong Pansi from Rashomon Isan Konkan campus. Today I'm going to talk about the bitrate. What is bitrate? Bitrate means how many bits that we can transmit in 1 second. And the equation to calculate is very simple, which is shown here. BR is bitrate and it is equal to logarithm base 2 of m times bandwidth or BW. The bandwidth can be symbol rate or sampling rate. They are the same actually, and this is the maximum we can get it. If we don't think about the coding rate or, for example, LDPC, RS codes, the bit rate will be reduced, but this is the maximum. Let's see. And the M stands for the number of levels that we want to transmit. For example, QPSK, BPSK, and 16 QAM, for example. And if we talk about 5G in Thailand, at the carrier of 2.6 gigahertz, I think the bandwidth is around 20 megahertz or less than this, maybe only 5 actually. And if we use 16 QAM, for example, and if you have a calculator, you can calculate it. It's very simple. You will get 80 megabit per second, and we increase from 16 to 64. You will get 120 megabit per second, and also if you need more, you can try to transmit 256 QAM, and you will get 160 megabit per second. And what about the 200 megabit per second, which is more than 4G now in Thailand? What M we need here? If you have a calculator, you will get it. The M minimum we need is 1024 levels or 1024 QAM, and the density is a lot here. You can see that means it's very sensitive to noise and sensitive to interference, sensitive to anything from hardware, from the channel. I believe we have no chance to get it with this 1024 QAM. But in Thailand, we have also now 26 gigahertz of carrier. The bandwidth may be 250 or 400 megahertz, and this kind of carrier region is this so-called millimeter wave carrier. So that means if we consider about 1 gigabit per second, the M we need is about minimum 16 levels or 16 QAM. And don't forget it, this is the maximum that we can achieve if they use a coding to minimize the error. The bitrate will be reduced from the last equation, and however, the problem is the more QAM orders, the more SNR is required, and it is less tolerant channel interference, symbol interference, any interference will corrupt or destroy the signal. For example, if we talk about only the SNR and the bit error rate of we are interpreted is 10 to minus 5 here. If we want to send or transmit the 4007 sorry, 1024 quam. Oh, what happened to me? We will get around the SNR at least. We need around 37 dB. Is a lot in the real practical. I believe we have no chance to get it. Okay, we can use other techniques, for example, space time code or coding technique. But anyway, in the SNR will be the same. I believe in the real practical world, 30 maximum or 33 maximum. So that means maximum, I believe we can transmit around 64 quam for the wireless communication. But for the optical communication, yeah, maybe we can talk about 256 QAM at the bit error rate of 10 to minus 5 and 16 quam now. The red right, I think no one think about it. I think everyone now, every company, every provider, they talk about 64 quam now, I believe. And again, today I'm talking about the bit rate, and the bit rate is increased when the M is increased or the bit rate is increased. For example, from 20 megahertz increase to 250 gigahertz, for example. And if the bit error rate is not considered, we will get this equation. Okay, so see you next script. If I have time, I will talk something else more. Goodbye. See you.